Start.
Very good morning. Myself, this is Neelima. I'm a geology faculty with 12 years of experience. So today our concept is exchange of gases. So I hope you all know that this topic is from human respiratory system or breathing and exchange of gases. Okay, let us start. So the concept is exchange of gases. Regarding exchange of gases is concerned, see, this exchange of gases occurs at two different levels. Number one, it occurs, exchange of gases is going to happen between alveoli and the blood. And second thing is exchange of gases occurs between blood and the tissues. Yeah. See, first one, exchange of gases between alveoli and blood is what we call it as external respiration. And the second one, exchange of gases between blood and tissues, it is called as internal respiration. And of course, even though we have external and internal respirations, today I am going to concentrate upon the first one, that is external respiration. I mean to say exchange of gases between alveoli and the blood. Fine. See now, usually before the start of this external respiration, we need to talk about some introductory points like, see, we know that respiratory gases are only two, oxygen and carbon dioxide, we know that. And this exchange especially happens at the alveolus, isn't it? Because we know very well, like, respiratory system is broadly classified into two parts. Number one is conducting part and number two is exchanging part. Conducting part is mainly concentrated for conducting the gases, that's it. I mean, it is mainly meant for passage of the gases. Whereas this exchange part is mainly meant for exchange of the gases. I mean, see, we know that we are not going to inhale the oxygen directly from the atmosphere. We are going to inhale only air. As we know, air is a mixture of gases. So especially at the alveolus, that oxygen is filtered from the rest of the gases of the air. Yeah. So now let's talk about the respiratory membrane. Respiratory membrane. Of course, we can also call this with the name diffusion membrane. Yeah. So what is this respiratory membrane? See, for example, I took one alveolus. This is a very famous picture. This is alveolus and this is pulmonary blood capillary. Pulmonary blood capillary, because we know that the blood vessel which approaches your lungs is pulmonary blood vessels. So this is the pulmonary capillary, alright. So wall of this alveolus and this pulmonary capillary, yeah, especially here you can see there are, strictly speaking, there are 5 layers which combinedly forms your respiratory membrane. 5 layers which especially forms your respiratory membrane. Number 1. Wall of the alveolus is actually made up of, see, wall of the alveolus is called as alveolar epithelium. We can also say that this alveolar epithelium is also called squamous epithelium because it is made up of simple squamous epithelium. Right. And then come to the case of wall of this capillary. See, we say wall of the capillary is called capillary endothelium. Of course, this is also made up of the same tissue, that is simple squamous epithelium. Fine. Super. Now, see, I simply wrote basement membrane, but of course while explaining I have to specify that this basement membrane is there separately for both alveolar membrane and also for this capillary endothelium. As we know, epithelial tissue is avascular. Everywhere in your body, if you notice this epithelial tissue, there you do notice this basement membrane because just beneath the epithelial tissue you have connective tissue. Super. So now, alveolar epithelium is having basement membrane, its own basement membrane, and capillary endothelium is also having its own basement membrane. Super. So, in between these two basement membranes, can you notice a narrow space over here? This narrow space is called interstitial space. Interstitial space. Now, all these combinedly forms your respiratory membrane. What I told you, the another name for respiratory membrane is diffusion membrane. Fine, super. Now, let us discuss about how this exchange of gases is going to happen, right? See, exchange of gases, of course we know that we are discussing at alveolus. So this mainly depends upon, number one, thickness of respiratory membrane, It mainly depends upon thickness of the respiratory membrane. Number 2, solubility of the gases, and I'm going to erase this respiratory membrane since we already explained this thing. And number 3, it is the partial pressure of the gases. Fine. So especially exchange of the gases depends upon these 3 factors. Number 1, thickness of the respiratory membrane. Number 2, solubility of the gases. And number 3, partial pressure. So already we discussed about this respiratory membrane, so I guess no need to explain separately about the thickness of the membrane. We are already done with that. And second thing is solubility of the gases. See, come to the case of solubility of the gases. As we are discussing about the respiratory system, we need to talk about the respiratory gases like oxygen and carbon dioxide. We know that the solubility of the carbon dioxide is 20 times more than that of oxygen, isn't it? Carbon dioxide solubility is 20 times more when compared to that of the oxygen. So this is about the solubility of the gases. And mainly come to the case of partial pressure, which is the concept of the day. See, come to the case of partial pressure. Partial pressure, of course, we indicate like with small p and O2. This is the partial pressure of oxygen. And small p and CO2, this is the partial pressure of carbon dioxide. Yeah. Let us discuss about the partial pressures, how they are going to define my exchange, how they are going to control, influence this exchange of gases. Yeah. So the main factor, that is partial pressure. See, once, now we'll just discuss about individually the partial pressures of oxygen within the alveolar air and this deoxygenated blood. Can I say that this is deoxygenated blood? Because this is pulmonary capillary, obviously it is going to carry deoxygenated blood towards the alveolus, right? So now, let us see the partial pressures of these gases. Partial pressures of these gases. So first what I'll do is like I'll write separately these two, and now within the alveolus how it is going to be, and within the pulmonary capillary how it is going to be. Fine, super. Now let us see how it is going to be differ. See, partial pressure of oxygen within the alveolus, it is 105 mm of Hg. The same partial pressure of oxygen within the pulmonary capillary, I mean it is carrying the oxygenated blood where it is just 95 mm of Hg. So now come to the case of carbon dioxide. Carbon dioxide's partial pressure within the alveolus is 40 mm of Hg, whereas within the pulmonary capillary its partial pressure is 45 mm of Hg. Okay. So from the simple tabular column, we can able to understand like what is the main pathway, how these gases are going to be exchanged. So as partial pressure of oxygen within the alveolus is 105, of course, which is greater when compared to the of its concentration within the pulmonary capillary. So I can say that oxygen is going to exchange or transfer from alveolus into this pulmonary capillary, pulmonary blood. Whereas carbon dioxide, when we come to the case of the carbon dioxide, its concentration within the alveolus is less, that is 40. When compared to that of the deoxygenated blood of the pulmonary capillary, which is 45. So obviously, from this deoxygenated blood, carbon dioxide is going to travel into the alveolus. So I'll write CO2 here, I'll write oxygen here. Fine? Super. So now this is the exchange of the gases. I hope you understood like exchange of gases mainly here. It depends upon the partial pressure, concentration gradient of the gases. Fine. Before I am going to, so this is about the exchange of the gases at alveolar level. As our topic is at the alveolar level, this is the exchange of gases at the alveolar level. So which is otherwise called as internal respiration, sorry, external respiration. Before I am going to conclude this, I have to add a small definition here, that is diffusion capacity. Diffusion capacity. So with this definition, I am going to conclude this. What is the meaning of this diffusion capacity? It is nothing but the volume of gas which is going to exchange per minute per 1 mm of Hg difference in the partial pressure. I repeat very slowly. The volume of gas, I am explaining diffusion capacity. listen to me